So hi everyone, I'm Dan Moller. What I'm really excited to show you today is how easily you can take any kind of artwork assets you've already got, push them through the DCC pipelines you're already using and get them into Spark, where you can add logic and then easily publish out to Facebook and Instagram. This is going to get your collateral working harder for you to help you connect and engage even more with your fans and followers. A little bit about me, I'm a prototyper on the design team for Spark AR Studio, and I have a background as well in kind of high-end visual effects production, including AR and VR. In my role now with Spark, I act sort of like an internal representative for the creator community. So I liaise, advocate for, translate for the community when working with the internal development teams to help make sure working with Spark AR Studio is the best experience it can possibly be. We're going to be using Spark today in a walkthrough. Can I just see a show of hands? Is anyone planning on actually following through step by step? A couple around the room, awesome. For those of you who are not, no stress, there's going to be plenty to have a look at. You're going to be fully entertained, I'm sure. So for those of you who are going to be following along, we have Patrick and Aniket over here. So if you get stuck at any point, please just raise your hand and they'll come and help you out. You did have some swag bags on your chair when you came in. You'll notice there's a thumb drive in those. That has some artwork assets on there that we'll be using in the follow along. So if you want to get them onto your laptop, if you don't already have Spark installed, you can try and grab it now. There's a URL link to the download site for Spark on that thumb drive as well. Try and grab it. We'll get into the follow along in about 10 minutes time. So you've got a little bit of time to get up and running. If you don't manage to make it work, no big dramas. I believe this talk's going to be online a bit later, so you'll be able to keep those assets, follow along in your own time, being able to pause and resume at will, okay? So first, I'm going to get started by showing you some great examples and a bit of background info, like this project featuring the two effects created by DreamWorks using Spark AR Studio for the Facebook camera. They feature Toothless and Light Fury on the left and the right from How to Train Your Dragon, which were adapted from the original film production assets. They were also used for an accompanying VR experience. Now, using Spark AR, you can really easily add interactivity. You can see with Light Fury on the right, when you tap on the screen, you can feed her a fish. And I really, really love the beautiful texturing and animation that we have on Toothless on the left. I think that really goes to show how readily AR lends itself to these same kind of VR assets that we're all familiar with working with. So I mentioned that these effects are created for the Facebook camera, and we're also super buzzed that the AR beta for Instagram is now open too. That means that anyone can now publish branded and unbranded effects for Instagram. So our vibrant creator community, I love them to bits. They've already been publishing loads and loads of effects. I love seeing these things come out. It's super exciting. Let's take a look at just a couple of them. Oh, quite a bombastic little piece. So with this beta now open, you've now got access to one of the world's largest visual sharing platforms. And you might have heard this figure a couple of times, but I think it bears repeating that we've now had over 1 billion people use experiences that were created in Spark AR Studio. So I find that makes my head spin a little bit. It's quite the responsibility. But the upshot is that between Facebook and Instagram, you really do have the ability to give your content significant reach. So we're going to dive straight in now to a bit of live demo. So if we can switch the screen over to live demo. Maybe, hey? Are we able to switch to the live demo? Yeah, there we go, cool. So what I'm going to do is show you, first of all, just a little bit of Swift bolting stuff together before we get into the follow along, okay? So we've still got a little bit of time. I'm going to start off by grabbing an asset known as a block. If you were in Campbell's presentation just before, you might have heard him mention blocks. Let's see, can I grab this? Drag, there we go. I'm used to using a mouse, everyone, so you got to bear with me. So a block is basically a prefab package that we can put all sorts of stuff into it. In this case, this block has models inside it, shaders, textures, lights, and so on. We can put logic and interactivity in there. They're a great way of sharing work between a team and reusing assets. So I'm going to show you in a next step where this artwork came from, but for now, I just want to show you how fast and easy it is to get your logic and interactivity built up inside Spark. So I'm actually going to count the clicks as we go. We've had 1 click so far for me to drag our diving bell over. I'm going to now click a second time and a third time to create a face tracker. We can see now we have a little pivot there, moving with our simulator model's nose, telling us that the face tracker is running. So that's been 3 clicks so far. With 4, I'm going to drag the diving bell onto the face tracker. So we have our old-timey diving bell now tracking with his face, just like that, in 4 clicks. Now with 5, and with 6, and with 7, I can send this effect as it is to my phone. I then get a notification ping on my phone. I tap on that notification, the Facebook camera pops open, and there's the effect running right there. So I don't know how you guys feel about this, but the first time I saw this running, I was like, Spark, I can't code, I can't do that stuff. I can code a bit. But it really did blow my mind seeing, bam, how fast that happened. Of course, if you have your Facebook and your Instagram accounts linked, then you're able to push straight to the Instagram camera as well. Cool. So you might be thinking now, that's great, Dan, but what kind of witchcraft did you use to get the diving bell to align to his head just like that? There's nothing too mysterious here. The first thing to remember is that under the help menu, you have access to download face assets, which is a package of face reference assets. Let's have a look at what they look like. If I switch over to Maya, you might be using any kind of 3D DCC. For me, my background's in Maya, so it's where I end up. Here we have the face mesh that's come from the face reference asset. So if you're doing live markerless facial tracking, this is the mesh that is going to conform to the user's face. If you want to create a blend shape, you can use this. If you want to paint makeup or other kind of facial markings and so on, this is your guide to use. I also have the occluder head, which can be used to put objects behind the head when you're building experiences. And this is also a great volume indicator for when we're building our assets inside our 3D DCC. So if I now turn the diving bell on, zoom out a little bit and switch to wireframe, you can see how the head fits inside my model there. It's a great way to just make sure when it aligns in here, if I export it via FBX, DAE, or GLTF, it's going to go straight into Spark and align there too. When it comes to the hierarchy, there's really nothing that crazy here. I've got my diving bell group, inside that a front door group. You'll notice that the pivot for the front door group is right at the little hinge. For this, we're going to use that later to build some interactivity. Similarly with the shoulders, we have a pivot running right through the middle so they can rotate nicely, and the head group. In terms of shading, there are 3 main shaders here and a secret 4th one. I just have all of my objects assigned to the shaders as per usual. I've UV'd this into 0 to 1 space based on shader assignment. Spark will read non-0 to 1 UV space. So if you do want to use UDIMs, you can, but it won't automatically tokenize file names. So to keep things simple here, we've just gone with this approach. There is a secret 4th object I mentioned with a shader. That's this invisible plane just here, which is an occluder object. I'm going to use this with a special shader back inside Spark that will cut out all of the geometry that fits in behind it. So with that geometry all missing, we'll be able to see the video feed through it, and it'll look like it's on the user's head. Cool, so there really isn't anything otherwise too mysterious about this. If we can switch back to the slides for a moment, In the slides, I've got a demo of some technical requirements for models. If we can bring up the slides, I'll start telling you about those specifications while we bring the slides up. The first thing you need to remember with these models is, when it comes to working with models in your Spark scene, is to try to keep your total object count below about 50. That's not a hard limit, but for performance reasons, if you go much over 50, things might slow down. You should try to have maximum 50 objects. You should try to have a maximum 1024 resolution squared for any textures you have. Spark's going to cap them at 1024 squared. For any single object, try to keep it under about 20,000 polys. And for all of your objects cumulatively, keep it under about 50,000 and everything's going to be cool. If we can bring the slides up, I've also got one for the skeletal animation. So when it comes to skeletal animation, there's no overall limit to your joint counts. So skeletal animation is going to go in just fine. But again, for performance reasons, try to keep your joint count under about 20. There's also no, you can only have a single joint hierarchy. So don't have any loose joints. There we go. You should try to ensure that all of your objects have unique names, including the joints. If they have the same names, they're going to get scrambled a little bit when they come into Spark. Each skin vertex can be influenced by up to about 4 joints. And you should try to merge all skins into a single mesh before binding them to your skeleton. Again, just for performance reasons, and it keeps things clean. Okay, if we can switch back to the live demo, we're going to move over into Substance. Yeah, there we go. So we've exported our model out of Maya via FBX, DAE, GLTF, a range of formats that are supported. And I've also brought that into Substance, popular texturing DCC. So you can see here the UV layout for the accent metal shader. I've also got my base metal shader, a glass shader, and the occluder shader that we're not too worried about because we're going to completely reformat that. Working here in Substance for my texturing, there's really nothing too crazy going on apart from that. You can see we've got all our standard layers where I've done a terrible job of keeping all my layers named and so on. But importantly, if I look at the shader settings, you'll notice that we have the shader set to be PBR metal roughness. Okay, over in Spark, we've got a shading model called physically based. And if I'm using PBR metal roughness here inside Substance, then when I bring those textures back into Spark, everything's going to look pretty similar, fairly one-to-one. The other thing to remember is that if I go to my File and Export Textures menu, under Configuration, I've created a preset for Spark AR Studio where I have a diffuse texture in RGB, so diffuse albedo, 2 terms used interchangeably, a normal map in RGB, and an ORM. Now, for those of you who are not familiar with ORM, they're used to pack occlusion, roughness, and metallic into the RGB channels of a single image. By packing all of those together into that single image, it means that we're not having to call for each of those parameters that we want to use, so everything works a little bit more efficiently. So you might have seen this before in other packages, but it's something we rely on in Spark AR Studio when working with a physically based shader. Okay, so with that, we're going to dive into the hands-on section. Okay, so if anyone is following along, by all means, you go next one. So if anyone is following along, put your hand up if you do get stuck. So hopefully you've got a new blank scene open inside Spark. If you don't, we can go to File and New, like this. Keep in mind as well, there is another folder in that thumb drive. If I have a look at it, I've got a copy of it up here. It's called Adding Interactivity. So if your wheels completely fall off as you're following along and you can't catch back up, the first thing we're going to do is reassemble this artwork, the model with the textures on the shaders, and then we're going to move into the adding interactivity. So if you get lost during the textures phase, then just open this project here, adding interactivity, and I'll give you a yell when we've moved into that section. You can pick it back up from there. Okay, so we're going to start now assembling these textures. So The first thing I want you to do is if we go to the artwork assets folder on the Spark thumb drive, we can select, shift click all of these. Let's see how my click and drag works in Mac here without a mouse again. We want to select all of these objects and drag them all together. Come on, man. We want to grab all of them and drag them across into the assets panel here. So this has the textures in it, has the model, and it's also got a couple of other special source assets that I've already made, just to smooth this along. The first thing we want to do is to grab the diving bell model and instantiate this into the scene panel. So our assets are our library, the scene panels where we assemble things, and the viewports where we see what's going on 3D spatially with the simulator, representing what we're going to see on the phone screen. So I'm going to instantiate the diving bell. I can also right-click, choose instantiate. That copies it up into the scene panel, and we now see it here in the viewport ready to go. So now that we've got our model set up, we're going to start assembling the shaders. So there are 3 shaders here: glass shader, accent metal shader, and base metal shader. The 3 with the little white icons. For these, because they're all the same type, over in the properties inspector, if we change anything in here, it's going to update for all 3 of them at the same time. Okay, the first thing we want to do, if you remember from Substance, I was talking about our physically based shader. So if we go to the shader type at the top, we can change these 3 shaders to physically based. We now have a slightly chalkier appearance to the model overall. We're also going to apply some nice lighting to this via an HDRI environment map. To do that, we want to make sure we've turned on environment calculations. So with all 3 shaders still selected, we'll click this little checkbox here for environment. Now we're going to set up some lighting so we can see what we're doing as we're building these shaders. We're going to do that by going to the Assets panel, choosing Add Asset, going to our Environment Texture Presets, and then Machine Shop. All right, Machine Shop's one of my favorites. It's got some good color, some good contrast, and I actually use the same HDR over in Substance, so we know we're going to get a really good one-to-one look. You can see the 360 with its full bit depth over here. Now I want to go to the Scene panel, and under Add Object, I'm going to scroll to the bottom and choose Environment Light. So that's Add Object, scroll to the bottom of our New Objects menu, find Environment Light, and Insert. With the Environment Light selected, over in the inspector, we can now choose Texture and then select the Machine Shop. So you'll notice that suddenly our image has gone really blown out. It's a bit too bright. A part of the reason for that is that all of our shaders are still set to be shiny white, but we've also got our default ambient and directional lights in the scene. We don't want them anymore because we're lighting our model and reflecting into it just using the environment light. So with both of those selected, I'm going to hit delete. We can now see we're getting some lovely reflections going on, and we're ready to start assembling the shaders. So the first thing I'm going to do is select the base metal. This is the most straightforward of the 4 shaders we're going to set up. You'll notice in our shader properties for our albedo texture, we've got a drop-down box. So I'm going to go to this drop-down box and choose my base diffuse texture, base diff, otherwise known as base albedo. And I'm going to assign this base diff to the albedo properties of the base metal shader. Next, I'm going to go to the ORM texture and choose my little drop down here, and I'm then going to assign base ORM. All right, we notice that disappointingly nothing's changed, but the reason for that is because each of our sliders here for metallic, roughness, and occlusion are currently turned all the way down to the bottom. These kind of modulate each of the channels that are coming in from the texture for these 3 parameters. So to see the effect of these, we need to dial each of these sliders all the way up to the right. Okay, once they're all dialed up to 100, we're now getting all of the information out of those 3 RGB channels coming out of the texture, and we're ready to go. The last thing we want to change on the base metal shader is the normal map. So for normal map calculation, we want to turn that on and consider that for this shader. And then under the texture box for normal map calculation, we'll choose the base NRM for normal. Cool, we now see we get some nice ripple here. The shaders are looking quite pretty, and we're seeing something that's really quite similar to what we had over here inside Substance already. Cool. Next one, we're going to move into the accent metal. For those of you who want to rush ahead, we're going to do the same 3 steps for the accent metal, and then we're going to pick up with a bit of extra special sauce on top. So I'm going to select accent metal. Under the shader properties for albedo, I'll now assign my accent diffuse, Under ORM texture, I'll assign accent ORM. Again, we'll turn each of those 3 sliders up. You're going to see that the model's looking pretty chunky, a bit dull and primitive and boring. That's because we don't have the normal map applied, where we've baked in all that nice beveling along the edges and the other rusty details and some screws and nuts and bolts and things. So under a normal map calculation, I'll turn on normal map and then plug in the accent NRM as well. So now things are immediately looking pretty sassy. You'll notice as well, as an extra step on this, the accent metal I've made quite silvery on purpose. That's because this silvery kind of color lends itself well to tinting with another color. So under the albedo properties, we've got a little swatch. This is currently set to white. We can use this to tint the texture color. So if you want to personalize yours, we can dial in any kinds of wacky colors we want. This is a really great trick for keeping your effect file sizes really low while introducing a bit of variety, because you can just use the same texture over and over again and tint it different colors each time. I kind of like this brassy color. I'm going to click OK, and we're done. Now we can move into the glass. So I'm going to grab the glass shader. The first 2 steps are the same as previously. So under the albedo texture properties, we're going to assign glass diffuse and glass ORM. Hopefully we're remembering the sliders, so we'll turn each of those sliders up to get full power from my ORM channels. And we can see we've got some really nice kind of tarnished metal look going on, but it's not looking like glass at the moment. Reason for that is by default we've turned off transparency calculation, again performance consideration for real time. So I'm under my render options. To get that alpha channel to come out of the diffuse texture, we need to change our blend mode from replace to alpha. So by changing my render options blend mode to alpha, we see we're now getting some nice transparency here. There's one other little gotcha. That's that if we pan around to the back, that glass disappears. As is the case with most real-time engines, by default we have double-sided turned off for performance. So to see the glass from the back as well, under our render options, we turn double-sided back on. Cool. We now have most of the shading work done. Our last one is just the utility for the porthole window. So I'm going to select my occluder shader, and we don't need to calculate diffuse lighting or reflectivity or anything like that for this. So we can switch our shader type to a flat model, which again, is going to keep things a bit more performant. Then we want this to be see-through, just like the glass. So under blend mode, I'm going to change my blend mode from replace to alpha. And lastly, we've got our opacity slider. I'm going to drag this all the way to the bottom. Now, because of a quirk of the way the occluder geometry is positioned in the hierarchy, combined with the different depth rendering flags and the fact opacity is turned all the way down, we're now not going to render any other geometry behind that plane, so we can see our model face peeping through the porthole window nicely. Cool. At that point in time, we've got all of our artwork back up to that same point. We had it hidden inside the block, so all pretty straightforward. So we combine this with the 7 clicks that we took last time to get it onto the Facebook camera, and you can see how fast these effects can be to develop. So if you've fallen behind, if you want to pick it back up with the adding interactivity, this is the time to go from that project. So for adding our interactivity back on top, just as we did with the block, I'm going to choose Add and Scene Understanding and Face Tracker. Now, some people struggle with this one a little bit. To parent the diving bell to the face tracker so it moves with it, we drag the diving bell on top of the face tracker. Importantly, we need to make sure we get this little blue rectangle showing up. If we have a little line, we're saying make it a sibling of that instead. Or a sibling below as well. By having the rectangle, we're saying parent this object to that object. Okay, so when I release, we now have the diving bell moving with the face tracker, just like that. I love it. Next, we're going to use some visual programming to make the portal window move with the head movement. I think it's going to be cool if we can have the portal window closed, and when you shake your head, the portal window flips open, and when we shake it again, flips shut. So to get this working, for the diving bell, we open it up and open it up again. So where our diving bell is, we open it up to get the diving bell group, and then we get the front door group. And we can see that pivot showing up just like it was in Maya. With the front door group selected, over in the Properties Inspector, we can access things like visibility and transformations. So we have position, scale, and rotation. Obviously, we want this door to rotate. We want it to open up, yeah? So we have our three parameters for rotate X, Y, and Z. And you'll notice just next to rotation, we have a little input arrow here that lights up yellow when I'm hovering over it. If I click on this arrow next to rotation, the patch editor pops open. And this is where we start to string together patches that perform little logical operations with cables that pass data between the patches. All right, automatically, we've also had created for us a patch called front door group with 3D rotation input properties. This reflects everything we see up here. So if we feed information into here, then it's the same as plugging it into here. Cool. So I was saying it's going to be cool to control the door rotation using the rotation of the head or triggered by the rotation of the head. So that tells us we probably need to understand something about how the head's moving. And fortunately, we've already created that using the face tracker. We already know how the head's moving. So to bring the information coming out of the face tracker into the patch editor, we simply do just that. We grab the face tracker and drag it down into the patch editor and release. You can see now this comes in as 3 patches. We have the face tracker 0, which is this object here, but we've also got 2 secret patches that are feeding information into it. What are these things doing? The face finder is looking at the camera feed that's coming in, and it's detecting faces in that camera feed, and then it's assigning indices, so an index to each face that it detects. That's being passed into a face selector that's then saying, hey, whichever index I've got selected here, just grab that one face and pass it through to the face tracker. The face tracker is then generating 3D position, scale, and rotation values for that face that we can then code around with and do whatever we like. It's also passing through the face signal. Okay, for this next step, I want us to zoom all the way out. So these patches are all nice and small. So use the scroll wheel or pinch to zoom out. We can then marquee select these 3 and move them all the way over to the left. I then want to grab the front door group and move that all the way over to the right. We want a nice big gap in between that we're going to fill up with a whole bunch of patches that are going to control the logic for the head shake. Okay, so if we scroll to the bottom of the assets panel, just like the block, I've got a patch asset here, which is a collection of patches that are controlling some logic. We can reuse those, we can share them across a team and work collaboratively. And I've prepared this for you so we're not fiddling around with too many bits and pieces. If we drag this patch asset into the very middle here and release it, let's make sure it's sitting nice and centrally with a big gap on this side, big gap on this side. And when I zoom in, you can see we've got this custom little patch called door logic. It's expecting a face signal to come into it, and it's also going to output XYZ vector coordinates for rotation. If I select the little port, it comes up with this little preview telling me the data that's coming out of it. I'm guessing you can bet what we're going to do next. We're going to grab the output signal for face from this port. If I click and drag from that port, I can drag it over to the input face port for my door logic group. And from there, I can also grab the output value and drag this over to the 3D rotation. When I release, the door slams shut. So the logic's already running. We've got a whole bunch of stuff happening in here we're going to look at in just a second. And if I switch to my FaceTime camera, there we go, running nicely. Hi, everyone. If I shake my head, the door pops open, super cute. And if I shake my head again, come on, slams shut. Lovely, just like that. I can switch back to the simulator video so we don't get too distracted. And let's have a look at this door logic. So this is a group of patches. If I right-click on the group, I can choose ungroup. Everything pops back open, and I can see all the logic that I've constructed in there to build this effect. All right, I'm not going to go through every single detail here. It's going to be pretty boring for people following along, and you won't retain it, but you can always watch this later and reconstruct it if you like. But importantly, we have the face signal coming out of the face tracker, which is going into a head shake patch. All right, so this head shake patch is saying, hey, here's a face. Is that face shaking its head? And if it is, it generates a pulse signal. We then process that pulse signal through here. And the pulse signal ultimately becomes an animation progress signal that's going into a transition patch. So this is saying, I want you to move from whatever's set at the start here to whatever's set at the end here. And I want you to modulate it by the curve. I've got the curve set to elastic out, which was what was giving the door that recoil and making it bounce when it opens up. And switch back to my webcam here. If I change this curve from elastic out to linear, when I shake my head now, you see it just robotically and linearly kind of swings shut, and it's boring. I prefer this curve much more if it's set to elastic out. So it's a really handy way to just get some ready-made animation in there. So if I shake my head again, boing, there we go. I love it. And yeah, signals coming out of there, straight into the front door group, and away we go. So when it comes to patches, if we want to make them, you can right-click in the patch editor, which brings up a whole bunch of categories for effects. And then we have the patches themselves with a bit of information about them. So if I look at interaction, for example, we can see I could create a patch for blinks, for eyebrows lowered, eyebrows raised, is the head nodding, is the head rotating, is the head shaking, is the left eye closed, and so on. I can select the patch that I want. You can see I'm already getting a little preview for it, what it's going to look like. I can then click Insert Patch, it gets dropped in there, and I can wire it up. So in this way, we can really easily create really sophisticated effects. If you think that we can then combine that with patch assets, you don't even need to assemble this stuff yourself if you're working with a developer on a team who's doing it for you. Cool? And so for many of you, this kind of visual programming is going to be really easy to understand, to see, oh yeah, cool, I can kind of trace this through. But there are also going to be a lot of you who are more familiar with scripting and you're more comfortable in that space. That's no problem at all. Over in our assets panel, if we go to the Add Asset button, you can see we can create scripts. This one's grayed out because just like the patch asset, I've already created it. We can only have one per effect at the moment. So I have a script.js here. It's a JavaScript script in a reactive programming model. And if I double click it, it pops open with pretty much all of the default settings that any freshly made script is going to have. Okay, I've just added 4 lines here that I've commented out with 2 forward slashes. We'll go through those in a sec. First thing that we're bringing in is the diagnostics module. Next thing we're bringing in is the scene module. The scene module allows us to access objects that are here in the scene panel. And so let's go through what I've made here line by line, just swiftly. I won't bore you with too many of the details. If I delete these 2 forward slashes, I'm now also bringing in the face tracking module, which is allowing me to use face tracking functions. I'm then bringing in 2 lines here, which are creating constants and assigning to them some attributes to do with the shoulder group, and then drilling into the transform properties of the shoulder group. The interactivity that I'm going to try and build here using my script is, you'll notice at the moment that the shoulders are really locked. If I rotate my head, the shoulders are staying really stiff and it kind of looks really unnatural. Usually when people rotate their head, they don't also rotate their shoulders in the same direction. There's usually a little bit of a pivot though. So what we're going to do is read the rotation of the head and then multiply that rotation value by -1 and apply that to the shoulders. That'll cancel out the rotation on the shoulders so they stay put. But I'm not actually going to go by -1, I'm going to go by -0.8 instead, which is going to leave a little bit of rotation in the shoulders so it has a bit of natural movement. So in the last step, we'll uncomment this line back in again. We're now assigning to the rotation Y value of the shoulders some face tracking properties. We're drilling into its rotation relative to the camera transform and multiplying it by -0.8. Okay, Command S to save my script. This script now automatically updates into the project and it reruns. And you can see now as I rotate my head, the shoulders are kind of rotating a little bit, but it's staying a bit more flexible, a bit more natural looking, a bit more exciting. Cool. At this point in time, we're done. Pat yourself on the back if you managed to follow this through. For anyone who wants to, I've got some more information as well we're going to go through. But for anyone who wants to follow this through, you've got the thumb drive. I believe this video will be up online so you can see if you can recreate this for yourself. But from this point, we want to get our effects out of here. We want to publish them online. I'm going to quickly show you some information about how to publish. Okay, so if I go to File, with Spark selected, File, Export, I can export a .ar export file. It's going to give me a bit of information about my effect size. Is it small enough to go out to Facebook and Instagram, or do I need to reformat a little bit? And then I can save. I'll then be directed to the hub. So the hub is where we administer our effects. And if we can go back to the slides for a moment, let's see if we can get our slides up. So the hub, again, if we've got any effects already running, we can administer them through here. If we don't yet have any effects published to our account, you're going to see something like this. All right, we've then got a button there for upload effect. We can begin the upload effect process. Okay, I'm not going to walk you through every step, but it's pretty well signposted and pretty easy to grok. The important things that I want you to remember is, first, you're going to need an icon. So you need to prepare this in advance. It makes your effect more discoverable, prettier, people can access it more easily. The second is that you're going to need a demo video that showcases what your effect does and just proves it works right. There are two functions this does. The first is that all the effects are human reviewed to make sure you're not doing anything crazy inappropriate, and also just to make sure it performs as expected and it's not completely busted. The second is that that becomes kind of marketing collateral, and that demo video appears across discovery surfaces on Facebook and Instagram. Okay, so you're saying, Dan, that's great. I've made an effect and I've published it. Like, how do people find it? If you've published a branded effect, there are three main places people can find it. First, on the left-hand side there, any account that has effects running on it is going to get this effect surface, an effect tab with this little sparkle face button right in the middle. In the middle image there, if someone creates a story using your effect, there's going to be an attribution link to that effect up at the top. People can tap on that, dive straight in, and depending on the settings on your account, you may be able to add call to action view effect links that users can swipe up from the bottom. Thirdly, using the hub, you can generate sharing links. Those sharing links can be sent out via regular web links directly. They can be encoded into QR codes and so on, so people can really find your effects quite easily. If you've made an unbranded effect, that'll also appear in discovery surfaces. There's an effect explorer, and anyone who's following you will get your effects in the bottom of their stories camera when they're in effect mode. Okay, so there are loads of entry points to these effects. All right, now hopefully you're thinking, okay, now I know how people can get to them, but what kind of effects work and what kind of effects don't? I've got a little bit of information for you about kind of marketing best practices. So the first thing to remember is to serve a real need. Like, why are people going to want to use your effect? It might be that they're a real fan of your work and they just want to share their love of your work. That's a real need. It might also be that they want to look cool, they want to look beautiful, they want to look, they want to make their friends laugh. So just put yourself in the shoes of anyone who, you might be wanting to engage with your work, and make those considerations when you're designing it. Second, try and get out of the way. If the effect isn't personal to anyone, they're going to have a limited reason to share it with anyone else. So don't cover up the face too much. Don't overpower them with your effect. Try and find a balance between them and you. Next, minimize branding. No one likes to be a billboard. So if you've got too much branding all over the place, people might not like it. Try and keep your branding quite minimal. Maybe a good way to think about your effect is consider it a gift to your followers and to your fans. It's a really good way to get them to appreciate what you're giving to them. Next, make it easy and fun. You've seen from this interaction programming, either visual programming, scripting, or just those objects for face tracking and so on. It's really easy to jam loads of stuff into your effect, and it can be really tempting. But best practice, try and keep it simple. Try and keep it discoverable. And lastly, make it novel and unique. If it doesn't stand out, then people aren't going to, you're not going to catch their attention. They're not going to pick it up and share it. All right. So also, lastly, don't forget that while these face effects are really popular, they're really great. Just like Toothless and Light Fury, world effects can be a really great way to showcase your work. It might be a character, it might be a vehicle, an environment, a prop, something like that. So don't forget that world camera. So as a last example, I'd like to show you something pretty special that we've been working on. We're currently testing a version of Sky's Hold the World running in AR with content supplied by the production studio Factory 42. So Sky's Hold the World is a VR experience set at the Natural History Museum in London. It features a hologram of Sir David Attenborough. He's sitting opposite you, and you're inspecting specimens from the Natural History Museum. And as you are, he's narrating directly to you. It's pretty special. And you then put the specimens down, they come to life and they run around. There's a pterodon, this anaguera that's flying around and swooping at you and all sorts of cool stuff. But you'll notice in the bottom image here, we've got this really cute little trilobite, who's a fossil trilobite sitting on a rock. I've taken this asset, really kindly supplied to us by Factory 42, and with fairly minimal effort, just slipped it straight into Spark AR Studio. So starting off as a fossil that you see here, the trilobite's anchored onto this rock, which is in turn anchored onto a target tracking image of the world here. The trilobite wiggles, he falls off, starts walking around. I like this smile because I get this smile whenever I see this too. I love this little guy, he's super cute. I find this kind of content really compelling, and especially this education use case. I find it really wonderful and really special. I'm hoping you're getting excited about this kind of stuff too and starting to think about the kind of ways that you might like to use Spark with your work. All right, so I know this has been pretty bam, 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 action-packed with a wall of noise coming from me at you. But if there are three things in particular that I'd really like you to take away from today, the first is that it's really easy to leverage your existing pipelines. So for those of you who are already using these production DCC packages to generate artwork, you're using the same stuff to then get your bits and pieces into Spark. The next is that between those scene objects like face tracking, visual programming, scripting, adding interactivity and logic is fairly trivial and fairly quick and easy to do. And third, the publishing process is pretty straightforward as well. All up, this gives you access to some of the world's biggest distribution and sharing platforms, especially Instagram, one of the world's largest visual sharing platforms. And I'm going to reiterate that point, that since we've launched the platform over the past year, we've had 1 billion people experience this stuff that's been made using Spark AR Studio. So with that, thank you so much for coming along today. I'm going to head to the speaker pavilion now. Patrick, was it running? Yeah! Secretly as well, I scheduled the effects. So using the hub, you can schedule your effects. There's all kinds of cool stuff on there. I've scheduled it to go live on my account, Dan Muller VFX, while we've been running. So if you want to have a play around with it on Instagram, go grab it. I've added a little bit of extra nice stuff in there for you. So with that, I'm going to head along to the speaker pavilion along with Campbell and Matt Hansen. I'll be happy to take any questions you've got there. And please enjoy the rest of OC6 and have an amazing time. Thank you.